Hi students, today we are going to discuss application of matrices for solving system of linear equations. Okay, so what is system of linear equation? A system which contains more than two equations is called system of linear equations. And already we studied what is consistent and inconsistent system of equations. What is consistent system of equation? Consistent. A system of equations is said to be consistent if it has at least one solution. Okay. Inconsistent means inconsistent if system has no solution. System has no solution, then it is called inconsistent system. Okay, so to find the solution of system of equation, in this method we are applying matrices. Okay, for example, so to apply the matrices to solving the system of equations, we have to convert the given system of equations into matrix form. So how to convert a matrix form? Let me explain. Suppose I am taking three equations in a system. Let a11x plus a12y plus a13z is equal to b1. Okay, a21x plus b21y plus a21y, a23, a22y, a23z is equal to b2. Third equation, a31x, a32y, a33z is equal to b3. Here I am taking non-homogeneous system of equation. Non-homogeneous means here b1, b2, b3 are non-zero elements. Okay, this is system of equations. Now matrix form, I am converting into matrix form. Matrix form of above system of equation. Equations is capital A into capital X equal to B. So I am going to convert this system of equations into matrix form, which is in the form of A into capital X equal to B, where capital A, this capital A is called coefficient matrix. Capital A is called coefficient matrix. Which can be obtained by taking the coefficients of the variables as a first equation, taking the coefficients as a first row. So first row is a11, a12, a13. From the second equation, take the coefficients as second row. So a21, a22, a23. From the third equation, take a31, a32, a33. So this will give coefficient matrix capital X. Similarly, capital X is variable matrix. Variable matrix, which is obtained by taking the variables in the system of equations as a column. So how many variables are there? X, Y, Z. So taking the variables as column matrix. This is variable matrix. Now capital B is constant matrix. So we have constants B1, B2, B3 in the equations. B1, B2, B3. So arrange them as column. So B1, B2, B3. Okay. So if we have system of equation, convert them into matrix form. Then we can solve by using some methods. In that, first method is inversion method. We have few methods. In that I am going to explain first method, that is matrix inversion method. First method, matrix inversion method. Matrix inversion method. Matrix inversion method. Okay. In this method, this method is applicable. See here, this method is applicable. If coefficient matrix capital A is non-singular. What is the meaning of non-singular? Determinant should not be equal to 0. So this method is applicable if coefficient matrix is non-singular. So coefficient matrix is non-singular, then only we can apply the inversion method. So how to apply inversion method? So I am considering one matrix equation. Consider Ax equal to B. So after giving the system of equation, we can convert it to matrix form in this form. Then after, so here we are going to system of equation, we are going to find the values of variables. So this is variable matrix. Okay, after converting the given system of equation into Ax equal to B, then check the matrix A, coefficient matrix A, determinant is 0 or not. If it is not equal to 0, we can apply the matrix inverse method. So after converting in this method, post multiply with A inverse on both sides. So what you will get? Ax equal to A inverse into B. That implies I into capital X is equal to A inverse into B. That implies X equal to A inverse into B. So here, by multiplying A inverse with B, you will get some column matrix, and equating to capital X, you will get the variables. Let me explain with one example. Example 1. Solve the system of equation. System of linear equations. Linear equations using inversion method. Using matrix inversion method. Inversion method. Okay, solve the system of linear equation using inversion method. That equations are: first equation 5x plus 2y is equal to 3. Second equation is 3x plus 2y is equal to 5. So we have two equations. Generally, solving the equation, you can find the solution. That is general method. But here we are applying inversion method. So you have to use inverse method of matrix. So converting into writing in matrix form. Writing in matrix form. I am going to write in matrix form. What is matrix form here? Ax equal to B. What is A? Where capital A is 5 to 3 to. coefficient matrix. So I'm taking the coefficients as a rows 5 2 3 2, and capital X is variable matrix. So what are the variables? X and Y. And constant matrix is 3 5. See here, constants are 3 5. I'm taking in B, right? And coefficient 5 2 as first row, 3 2 as second row. Sometimes constant will be at left hand side. So if constants are lying at left hand side, you send it right hand side, then take in capital B. Okay, right. Now I am going to, in inversion method, A should have the det value not equal 0. Then only we can apply inversion method. So I am checking the det A. What is det A? How to find? 5 to the 10 minus 3 to the 6. So 4, which is not equal 0. Right? A inverse exists. A inverse exists. Now, how to find A inverse? A inverse equal to 1 by det A adjoint A. What is the formula for det into adjoint A? Already we found det for adjoint A. Adjoint A. What is the formula for adjoint A? Just interchange these two elements and then keep minus to these diagonal elements. Interchange these two elements for only 2 by 2 matrix. Interchange these two diagonal elements and keep minus to these two elements. Okay, I'm interchanging 5 2, so 2 5, and here minus 2 minus 3. So this is the adjoint A. Now I got A inverse. Now from equation 1, this one, we know X equal to A inverse into B. So by pre-multiplying with A inverse, you will get X equal to A inverse B. Right? Now to get X, A inverse matrix. What is A inverse matrix? 2 minus 3 5 into B matrix. What is B matrix? 3 5. Okay, so multiply this matrix, row into column, first row into column. So 2 3 is 6, minus 2 5 is 10, minus 3 3 is 9, 5 5 is 25. So that is equal to 1 by 4, 6 minus 10 minus 4, minus 9 25, minus 9 25 16. 16. Okay, 1 by. Now dividing by 4, you will get capital X is equal to minus 1 2. So minus 1 4. So I got capital X equal to minus. What is capital X? XY. XY equal to minus 1 4. Right? Capital X equal to, I got minus 1 4. Capital X means XY. XY equal to minus 1 4. So therefore here we got X is minus 1, Y is 4. So this is the solution. X equal to minus 1, Y equal to 4. Okay. For 2 by 2 matrix. So same procedure you can apply for 3 by 3 matrix also. Let me explain for 3 by 3 matrix. Problem for 3 by 3 matrix. Example. Second example. 2x1 3x2 plus 3x3 is equal to 5. X1 minus 2x2 plus x3 is equal to minus 4. 3x1 minus x2 minus 2x3 is equal to. So solve the given system of equations in inversion method. So I am converting it to matrix form. The matrix form of the system equation is system is Ax equal to B, where capital A is coefficient matrix. So I am taking the coefficients in first row 2 3 3 2 3 3. From second equation coefficients are 1 minus 2 1. From third equation 3 minus 1 minus 1. So variable matrix capital X. So here variables are x1, x2, x3. 3 variables available, and constant matrix is 5 minus 4 3. So constants, these constants I am taking in B. Now to apply inversion method, first you find data. We need A inverse, no? So I am finding a data. How to find data? 2 into minus 2 1 the 2 minus 1 the minus 1 plus 1 minus 3 1 minus 1 minus 3 1 the 3 plus 3 into minus 1 minus 2 3 the 6 plus 6. So that is equal to 2 into 3 minus 3 minus 4 plus 3 plus 1 6 plus 12 plus 15 27 33. Sorry, here I didn't do minus 2, this constant here of 3 minus 1 minus 2 3 1 minus 2. So here 2 to the minus 4 plus 4. So 5 2 5 the 10. And for this here for 3 also minus 2, here minus 2 minus 3 minus 4, so 15, right? So 30 40 is the tet. Now which is not equal 0, so A inverse exists. I need A inverse. For that I am finding adjoint. You know how to find the adjoint. Cofactors. So directly I am writing the adjoint. Later you can, if I give one problem, you find the cofactors, then transpose it, you will get the adjoint. So I am directly writing the adjoint here. Adjoint is 5 3 9 5 minus 13 1 5 11 minus 7 is adjoint. Okay. Now A inverse is 1 by dt into adjoint. 1 by dt 1 by 40 into adjoint is 5 3 9 5 minus 13 1 and 5 11 minus 7. This is A inverse. Okay, now from equation 1, from 1 we get x is equal to A inverse into B. So x is equal to A inverse into B. 1 by 40 5 3 9 5 minus 13 1 5 11 minus 1. This is A inverse into B. What is B matrix? 5 minus 4 3. Now that equal to 1 by 40 row into column. 5 5 is the 25, 3 4 is the minus 12, 9 3 is the 27. Next second row into first column. 5 5 is the 25, 13 4 is the minus 4 3 is the 12, 1 cal 4 1 is the 52, 1 3 is the 3. Next 5 5 is the 25, 11 4 is the 44, 21. Okay, 1 by 40. By simplifying this, 25 plus 27 minus 12, 15 15 30 40. Here 25 52, 77 80. Here 25 minus 44 minus 21, 25 minus 4 40 minus 40. Right. That equal to, by dividing 1 by 40 you will get 1 2 minus 1. So left hand side capital X matrix. What are the variables in capital X? X1 x2 x3. Right. So here we got x1 is equal to 1, x2 equal to 2, x3 is equal to minus 1. These are the solutions for 3 by 3 matrix. Okay. Right. Now one more example problem. If capital A is minus 4 4 4 minus 7 1 3 5 minus 3 minus 1. Capital B 1 minus 1 1 1 minus 2 minus 2 2 1 3. Find A into B and B into A, and hence solve the system of equations x minus y plus z is equal to 4, x minus 2y minus 2z is equal to 9, 2x plus y plus 3z is equal to 1. So first find A into B and B into A. Then after using that you have to find system of equations. Okay, the inverse method. Okay, let me find first A into B and B into A. A into B. Multiply product of A into B. So first row product, first row into first column, you will get minus 4 plus 4 plus 8. First row into second column, you will get 4 minus 8 plus 4. Next to first row into third column, you will get minus 4 minus 8 plus 12. Next to second row into first column, you will get minus 7 plus 1 plus 6. Second row into second column, 4 minus 2, 7 minus 2 plus 3. second row into third column, you will get minus 7, minus 2, plus 9. So third row into first column, you will get 5, minus 3, minus 2, minus 5, 6, minus 1. Next, last row into last column, 5 plus 6, minus 3. So after simplifying, you will get 8, 0, 0, 0, 8, 0, 0, 0, 8. That implies 8 into I3. So A into B, you got 8 into I3. Similarly, if you find B into A, again you will get 8 into I3. Find B into A, again you will get A into B. I am not solving here. If you solve, you will get 8 into I3. So what we got? A into B is 8 into I3. A into B is 8 into I3. And B into A is also 8 into I3. 8 into I3. Right? Here A into B, we got 8 into I3, and B into A also 8 into I3. Now we got A, B and B. By using that, we have to find the system of equations. Observe the system of equations. Coefficients are 1, minus 1, plus 1, first row. And observe the B matrix, 1, minus 1, plus 1. Second equation, 1, minus 2, minus 2. 1, minus 2, minus 2. So capital B is coefficient matrix. Okay. So to solve this equation, we need B inverse. Okay. After multiplying B inverse with constants, B inverse with constant matrix, you will get variable matrix. Okay. So here we need B inverse. No? If I divide by 1 by 8, here you will get 1 by 8 A into B. 1 by 8 into A into B equal to I3. And from this, by dividing 1 by 8 into A is equal to I3. So what we got? 1 by 8 into A into B. B into 1 by 8 into A is equal to I3. That means here what is the B inverse? B inverse is 1 by 8 into A. So to get B inverse, directly you can multiply A by 1 by 8, you will get B inverse. So system of equation, to solve system of equations, to solve this system of equation, we need coefficient matrix. Here what is coefficient matrix? 1, minus 1, 1, 1, minus 2, minus 2, and 2, 1, 3. Variable matrix, capital X is equal to X, Y, Z. And constant matrix I am taking as C, 4, 9, 1. 4, 9, 1. Okay. So Bx equal to C, X is equal to B inverse into C. X equal to B inverse. X equal to what is B inverse C? 1 by 8 into A into C. So here 1 by 8. 1 by 8. So B into C, by multiplying B into C, you will get 24 minus 16 minus 8. By dividing it, you will get 3 minus 2 minus 1. Okay, I didn't multiply. Here multiply A and C, you will get column matrix. Then divide by 8, you will get this values. So therefore X value is 3, Y value is minus 2, Z value is minus 1. Okay, these are the variables. So from this product we can get directly B inverse, that is 1 by 8A. 1 by 8A, substitute here and multiply A and C, you will get the values of the variables. Okay, so follow this procedure to solve the exercise problem. I will send exercise problems as homeworks, solve them.